So, in grade 8, for most of you, that is going to be the last time that you spent the whole entire chapter working on shapes, rectangles, and circles, and triangles. That's where it stops. But then the shapes sort of show up every once in a while in different chapters throughout different math. And it shows up in this polynomial chapter. And the two things that you need to be able to do with shapes, doesn't matter what the shape is, you need to be able to find the perimeter of it, and you need to find the area of it. Two things, right? So, first half of this page is finding perimeter, second page is finding area. So, the perimeter of a shape. So, if I gave you a shape like this in grade 8, a rectangle, and I said this is 5 and this is 2, so this is 5, this is 2, and I asked you to find the perimeter of this shape, what would you do? What is the perimeter? How do you find the perimeter of any shape? What does the word mean? Not square them. What does the word perimeter mean? Around the outside. So you add up all the sides around the outside. So in this case, you go 14. 2 plus 5 is 7, and you add the other 7, you get 14. All right? So whenever you ask to find the perimeter, we add all sides. That's the generic formula. Right? It doesn't matter if you have a triangle, a rectangle, or a weird polygon, right? However many sides there are, you add them all up. Now the thing that changes is in grade 8 is we had numbers like 5 centimeters, 2 centimeters, or feet, or something like that. Here, our sides are unknowns. They have polynomials in them. But the process is still the same. So if you want to find the perimeter of this rectangle, or sorry, triangle, we need to add 3 sides. We need to add this side, we need to add this side, and we need to add this side. Add 3 sides up. Right? And now we need to start remembering the stuff we did in January for adding polynomials. Right? There was 2 different ways. We can work horizontally, or we can work vertically. But I think for this, working vertically might be easier. So we have our first side, right? We have x plus 14. We have our second side, that's 2x plus 36. And we have our third side, x plus 14. Right? And we add all these sides together. Right? So this is like the vertical method we did, right? Adding them all up, right? Like term with like term, x's with x's, numbers with numbers, right? So you just add the columns. We have 14 plus 36 plus 14. What do we get? Right?
64.
64, yes. 64. Okay. And it's positive 64, so we put a little plus sign. And then we add all the x's together. Remember, if you don't see a number, there's another imaginary 1. 1x, 2x, 1x. How many x's do we have? 4. And should that x have an exponent? No. Remember, when we're adding, subtracting, the exponents don't change. We add things that are alike. We're just saying we have 1x here, 2x here, 1x here. Altogether, we have 4 x's. We don't change the exponents. Right? We don't change what we're counting. So, it's 4x. So the perimeter of this shape, it's not what you're used to seeing, is this. 4x plus 64.
Do you want us to solve for that?
Hmm?
Do you want us to solve?
There's nothing we can solve for it, unless the question gives you another number they don't have to work with.
Oh, well, we can't divide by 4 on either side to isolate x?
No, there's no equals. All right? There's no point.
Oh, I see.
All right? Okay. So, we have a rectangle. We have a 4-sided object. So we're going to add 4 polynomials together. Right? And if you prefer, you can write it out horizontally. But I'm going to write them out vertically because I think it's a little bit easier to see the like terms. 3x plus 3x, 3x plus x. And we have the x plus 2 and the x plus 2. You add up all the sides together, right? Numbers with numbers, x's with x's, right? 6 plus 6 plus 2 plus 2, right? What do we get? 16. 6 plus 6 is 12. 12 plus 4, 16, and it's positive. We put a plus sign. We add all the x's together. What do we get? 8. And it's an x, so 8x. That's it. All right? And with polynomials, they just got a little tricky. It can something like this, is if you had positive and negative integers mixed in. So you're a little bit careful with the signs. Remember, from grade 8, if you see a line markings on the sides, that means those sides are the same. So it's double line, so that and that are the same size. Single, that means those are the same size, right? So add up all of those together, right? Like sometimes I like to walk around the outside of the shape. Sometimes I like to stack the equal sides together. That way I can tell if I missed anything. All right? So 4 sides. All right? But now, some of the numbers have negative signs in it. So you have negative 10, minus 10, plus 2, plus 2. All right? What number do we get?
Plus 24.
All right? Not 28. Negative 16. Negative 10 minus negative 10 is negative 20. Plus 2 is negative 18. Another plus 2, negative 16. Gabe?
No.
All right? So remember, just work from your top to the bottom. If you had troubles doing that, just go turn this on. Let's clear this. You enter your first one number in as negative. Then you just go down. Minus 10 plus 2 plus 2. Just enter it from top to bottom into your calculator. And you get the number. All right? And do the same thing. 9 plus 9 plus 5 plus 5. What number do we get there? 28 there. Oh, that's where the 28 came from, William. All right? 28. And these are C's. So don't forget your C. And that's it. Okay? So I could give you a question and say, find perimeter if C is, let's say, 2. I could add that extra little step in, right? So you add all these together and say, hey, this is our formula for our perimeter, and this is what we're going to do next chapter, right? And we're going to say, oh, we know C is 2. So our perimeter is 28, C minus 16, and we're going to replace the C with the number 2. So where we see the 28, I'm going to put the 2 in. Then it becomes something to calculate. Then you go 28 times 2, right? So that's 56, right? 56 minus 16, 40, right? Equals 40, right? So we're not going to do too many of those, but that's where you're heading, right? Well, you can do a lot more of that next year. Perimeters and areas involving x's and stuff like that. So this year we're just getting used to not having numbers, having expressions on the side. Right? So perimeter, I think, is the easier one. Where students make the mistakes is they forget the rules and they start changing the exponents here and stuff like that. Just remember like term with like term, and the exponents don't change. Okay. What is harder is area. So perimeter is adding and subtracting polynomials. That was unit 3. Multiplying and dividing polynomials fit into the area formulas. Now, the perimeter was always, for most shapes except for the circle, it's the same formula. Add up all the sides. The area you need to know the area formulas for different shapes. And the basic ones are square, rectangle, and triangle that you need to know. Be great if you know the circle too. And do you know what it is, Evan, for a rectangle?
Do you have to square these ones?
Sort of.
Yeah.
So if I have a rectangle, I'm going to say area of a rectangle, draw a little rectangle there.
Is these ones a square?
Length times width. So this one, no, that was, that's Pythagoras you're thinking of there. So this is length, this is width. Actually, it doesn't matter if you mix these things up, right? So this was length times width, right? So whatever is here and whatever is here, you multiply those two things together. Okay? Then we had the area of a triangle. You guys remember what that one was? That one's a little bit harder to remember. Yeah. So a triangle is half of a rectangle. So if you imagine this, just cut in half. So the formula for a triangle is exactly the same for a rectangle, but just divided by 2, which is half the size, right? But the names of the sides changes. So on a triangle, we call this our height instead of our length. We call this base. This one is called a base. Here. So the base is the bottom. The height is the distance from the bottom to the peak. All right? So you go base times height, or length times width for a rectangle. Then we cut it in half, divided by 2. And I think most grade 8 teachers don't actually show you this formula. They use 0.5 because students struggle with this, dividing by 2, but now you see the normal way it's shown, right? We try to avoid decimals as much as possible because decimals introduce inaccuracy, so you start rounding when you have decimals. All right, so we're going to use these two formulas with these two shapes, right? So the first one is we have this rectangle, and we have area of our rectangle is length times width. Step 1, write down your formula. Step 2, fill in the information. We have our length. We have our width. All right? We replace it. So we go 5y times 2y minus 1. Now if I write it like this, it's not quite right. Okay? So the problem with the way I did it is I just took exactly what was above and wrote it down below, right? This length is multiplying the entire width, right? So that we need to put this in brackets. So this 5y is multiplying the entire width. So everything there, right? Okay, William? Yeah? Yes?
Would it be
Evan?
9 then? Because there's minus 1.
So now we use our multiplying rules. So either you set up your t-chart or do your arrows. Monomial times the first term. So yeah, 5 times 2 gives us our 10. And then we combine our y's together. So y squared. We have a 1 and a 1 makes us a 2. We add those together. Then we take it and we do the next one. We go 5y times the second term, right? So what do we have there? 5y. And we're missing a sign in between those two terms. Positive or negative? Negative. This is negative 1 times that. That's it. 5y times 1, nothing changes, stays the same. That's the area. Right? And the question could be further extended. I'm not going to do it right now, but it could be saying, hey, now I know the value of y is 3. what is the area? Then you can put 3 into it. We're not going to do it. All right. Okay, last one. And we're done. Area of a triangle was base times height divided by 2. Okay. There are 3 sides of the triangle, but we're only using 2 of our formulas. So you can't just be, rectangles, you can be a little willy-nilly, you just pick whatever sides you want, you'll get the right answer. Here you have to be a little bit careful. What 2 sides are we using? Sammy? The bottom one, which is our base. And the left one, he said, which is our height. Right? So we don't use the diagonal in the area formula. Right? So now we just replace it. We're going to multiply these 2 things together. Now, if I did it in the exact same order, I'd put the 4m plus 2 first, then the 3m second. It doesn't matter if you mix it around. I think most students prefer the monomial to be on the left. So I'll just write it on the left, even though that is the height. But if you wanted to write it the other way around, you could. Now, just like the previous case, long as you pick the 2 sides together, you're fine. Right? So. Right? Now, if the top numbers are reversed, it doesn't matter. You just do the arrows from the other side. Right? So, this is the hard question from our assignment. Very bottom, right? So, before we can divide, we need to get rid of those brackets. We take the monomial on the outside here, and we do our first multiplications. And what do we write down when we do that first multiplication? 12m squared. 3 times 4 is 12. When we're multiplying, we add the exponents. M and M makes 2. All right. Then we do the next one. And let's go for, what color? Gray. Right? The 3m times the 2. 6. Is that everything? M? Is that everything?
Yeah.
Nope. We're missing something. The addition sign. Plus. Right? The plus sign here. That's it. Then we still have that 2 sitting down from above. Okay? So this would be like a 3-mark question easily. Not 4. We take this. Now we split it up into our fractions. How many fractions do we split this up into? 2. There are 2 fractions, 2 terms on the top. Right? So there's a term here and a term here. We're going to split those up. We have 12m squared over 2 plus 6m over 2. And we clean those up. Right? Gabe, what do we get when we clean up the first fraction? Got it, Gabe?
Me?
Other Gabe.
6m squared plus 3m.
Well, thank you. 12 divided by 2 is 6. The m has nothing to combine with, so it stays the same. The next one, 6 divided by 2 is 3. And m has nothing to combine with. That's it. Right?